Okay, so good evening. My name is Matteo Chiesi. I'm a postdoc researcher at the University of Bologna, and today I'm here to talk about a little bit different topic because I'm talking about a cost-effective system for neuroscientific research. So together with my colleagues here at University of Bologna, we are working on neuroscientific research and brain-computer interface because these topics are very important. Brain-computer interface is changing the interaction between human and machines. So the idea is that our brain signal are taken from our scalp and then are processed with a PC in order to translate our signal in machine command or operation. And in order to do this, we use EEG because EEG presents some advantages over other techniques such as fMRI or PET because it's non-invasive, it is easy to set up, portable, and low cost with respect to the other technique. And basically, there are two kinds of commercial available systems, medical devices and consumer devices. The difference between these devices is that medical device presents a high quality signal, support a large number of channels, and you can use a standard BCI or general purpose tools such as MATLAB and Simulink in order to import and process your EEG data. The cons is the price, because this kind of system can cost up to $100,000, so very expensive and not affordable for research centers and universities. On the other hand, we have consumer devices, which present a moderate to high noise, and so the signal quality is not so good and do not support a large number of channels, just 10, 20 channels. And in addition, user cannot adjust the position of the electrodes on the scalp. So, how the perfect EEG system look like? We want a nice signal quality with low noise and high common mode rejection ratio, supports a large number of channels, and should operate under every operating system such as Windows, Linux, and Mac OS, should be affordable, easy to set up, and why not open source. So here we are. This is Cremino, our quick setup, cost-effective open source EEG system. And the name comes from an European project in which we develop this system, and Ino is because it's Arduino based. So the system consists in a quick setup cap that user can put by himself, a data conversion system, and a set of software and libraries that can be used to acquire and process EEG signal. In particular, the hardware, if you have a look on the picture on the left, is composed by active electrodes. Active electrodes means that we have onboard amplification. So this electrode is a wet electrode, so in order to create the contact between the skin and the electrode, you have to put a little bit of conductive gel in the hole. But this kind of electrodes are also compatible with dry electrodes, which means that you doesn't need to put any conductive gel or something like that. And the advantage of active electrode is that the setup time is very short, and you don't have to prepare the skin before to put the cap. The conversion stage is based on a 16-bit analog front end from TI, The system is modular, so you can connect more chip, and you can reach up to 128 channels. And this kind of system has a ultra-high common mode rejection ratio interference. So the controller is based on Arduino, as I said before, because Arduino is an open source and easy to use prototyping platform that you can use also for commercial purposes. So the entire system is powered by USB. There is also the possibility to synchronize the data acquisition with some visual or auditory stimulus. And obviously, it is compatible with Arduino shields such as Bluetooth, Wi-Fi, or movement sensor. So here I would like to show you a brief video. This is one of my colleagues that put by himself the cap. And on the right, you can see a countdown. And in more or less 1 minute, the system starts to work. This is the ground and reference contact. So in this case, we have a notch filter to remove the 50 Hertz. Okay. You adjust the cap. And now the system basically is ready to work. So, set up in 60 seconds. Now my colleague closes his eyes and an alpha rhythm oscillation appears. The notch filter now is off, so the system is pretty good. This is the MG artifact that happens when you move your eyes or your mouth. Okay, so the performance. The performance of the system are comparable with performance of a clinical device because we measure the performance according to the international standard. So the system presents a low noise. The amplitude of the noise in the time domain is shown in the first plot, while the second one shows the power spectral density of the noise, which basically presents no interference, and the integral of the power spectral density in the 0.5 100 Hz is lower than 0.5 microvolt, which is the value imposed by the standard. And in addition, this one is the common mode rejection ratio, which is 6 times higher than the level indicated in the standard. So we develop a custom-made acquisition software, a Java-based custom-made acquisition software with an interface. This software is capable of collect up to 64 channels, store, process, and visualize in real time, and works on Windows, Linux, and also on Mac OS. And in addition, we develop some drivers to import this signal in the most spread out tool for brain-computer interface, and such as BCI 2000 or OpenVibe, but we also provide libraries to connect the system to MATLAB and Simulink. So this is another great example. This screenshot has been obtained using BCI 2000, and in the left part, this plot shows 16 electrodes, is this configuration that you can see also here in the cap. The plot on the left show a man with his eyes closed, so you can see an alpha rhythm, which is an oscillation in the occipita region between 10 and 12 Hertz. And when the subject opens his eyes, you see eye movement artifacts. And then nothing else. So this is another example. We use the some toolbox from MATLAB. We import the data using AGLab, and this is simply a visual evoked potential on the right field. So the man is looking with his right eye, and you can see that the potential on the scalp are in the left part of the brain. So how much does it cost this system? Arduino Due is more or less 40 euros. An 8-channel board, with, you can see is here, costs more or less 50 euros and include also optical isolation. And each additional 8 channel costs 30 euros. So with 200 euros, more or less, you can compose, you can set up a system for a 32 channel system that has the same performance of a medical system, for medical device. So the ongoing activity is to develop custom and cost-effective dry electrodes, because in the video that I showed you before, we use commercial gold-plated dry contact that cost more than, one of these costs more than the entire system, because it costs more or less 100 euro, just one. So now we are currently developing the contact based on 3D printing, conductive or conductive silicone. And we plan to release the system. So I mean the schematic, the bill of material, the driver, the libraries, and so on by the end of the year. In addition, we would like to integrate the system with another board that performs transcranial electrical stimulation, which is a painful stimulation that now is spread out also in the clinical environment it is used to set up it is used for epilepsy, I think, and also for depression, for depression treatment, something like that. So we just this. We would like to add this board to the system. So if you like more information, you can contact me. This is my email address. And thank you very much for your attention. And enjoy spaghetti alla bolognese, as Davide said.
Any questions? We got a question over here. Oh, go here first.
Thanks, man. My name's Ajit. Actually, I just wanted to ask, would you have any plans to do this in a clinical setting or try to do...
Clinical? No, nothing clinical, because you have to certify the device if you want to do something clinical. So I think it's quite expensive to certify a device like that.
Just out of interest, a full clinical device or whatever, like a full professional version of this, what does it cost?
This one, 32 channels, more or less 30,000 euros, I think, something like that. It depends on the number of channels. Yeah. But 128 channels, it costs 100,000 euros.
So you're potentially 2 orders of magnitude cheaper than the professional stuff. Wow. Any other questions? Cool. All right. Thanks, mate. That's cool.